Well, welcome to Chapter 6, and keep your calculators handy. We are going to be learning about normal probability distributions. So there's a calculator function to find values for these for this normal probability distribution function, just like there was for binomial. So first of all, what is a normal probability distribution? Well, it's a function y equals f of x, and it's got this complicated equation. Notice that it depends on the mean and the standard deviation of distribution of data that you're given. And it's just the bell-shaped curve. So a normal or a bell-shaped curve follows a normal probability distribution. There's lots of data that's normally distributed, weights, heights, IQs, any kind of standardized test scores. Those were all normally distributed. Lots of data is normally distributed. So this bell-shaped curve has the mean in the middle. And then I've marked 1, 2, 3 standard deviations to the right and 1, 2, 3 to the left. So this is the mean plus sigma. This is mean plus 2 sigma. And the last one is the mean plus 3 standard deviations. And then going the other way, you subtract. So mean minus sigma, mean minus 2 standard deviations, and mean minus 3. So, and that's always the case. So if you shift the mean, then that's going to shift it left and right on the number line. And sigma, the standard deviation, is right here. If you change the standard deviation, that's going to change the width of the curve. So for example, let's say that we know that our mean here is 10 and our standard deviation is 3. Then in that case, our bell-shaped curve for this data is going to have a mean of 10, and then you mark off in threes. So 13, 16, and 19. And then the other way, you subtract 3. So 10 minus 3 is 7, minus 3 is 4, minus 3 is 1. So notice here again that this is the standard deviation. Now, these are the x values, and it's always the case that the z-scores that span the normal distribution are 0, 1, 2, and 3 standard deviations above, -1, -2, -3, 3 standard deviations below here. And then the important thing to remember about the probability that x is between a and b on this normal distribution, a is a constant, b is a constant. Well, what that is that's area under the curve between a and b. It's also the proportion of the data that's between a and b. So probability equals area equals proportion. All right, you should be able to try homework 6.1, problems 1 through 6.